So you want to start writing software for the Commodore series of machines, such as the Commodore 64, VIC-20, plus 416, etc. But you want to use modern tools. Well, this video is for you. I'm going to walk you through how to set up a brand new Windows installation with just enough tools so you can build a development environment so you can learn how to write assembly language for Commodore 8-bit computers using modern tools. In your environment, you may have some of these tools installed already, and that's okay. I'm just walking you through how I like to install the tools. So this video is going to cover installing Git, Java, Kick Assembler, Vice, and Visual Studio Code, and we're going to configure Visual Studio Code to integrate with the Vice emulator. So there's a lot to do here, so let's get started. The first thing we need is Git. Git is modern version control. This is so we can make changes to our software and keep a history of it and go back in time if we need to. And you grab Git for Windows on git-scm.com. We're going to click this link here. We're going to click the 64-bit for Windows setup. And we're going to open it. So the installation of this has a few little options that we want to tweak. So don't just blast through the next button on this. So we want to turn off Git Bash here. We're going to change this default editor to use Notepad, as we don't have Notepad++ on this machine. Notepad++ is a phenomenal piece of software, by the way. I'm going to click Next, 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 Next. We're going to use the Windows default console window for this. And next, next, next. Git is now installing. And now we have Git on our machine. So now we're going to press Windows R, type CMD to get ourselves a command prompt. So to configure Git, we need to tell it what our name is and what our email address is. And to do that, you type in git space config space -- global user.name, and in quotes, we'll just put our name, my developer thoughts. Okay, we're going to press up. Then we're going to change an email address here. And then you just put your email address. So we'll put your email at gmail.com. And of course, we know Git is installed because those commands work successfully, but I usually like to do git -- version to make sure the software is there. And there it is, Git version 2.44.0 for Windows.1. So then we have version control. Now we need Java. Why do we need Java? The Kick Assembler software is written in Java and needs the Java runtime to run. So to grab Java, you're going to go to java.oracle.com. My personal preference for versions of Java is the latest LTS version. Kick Assembler just needs Java 11 or greater, but we're going to use the most recent LTS, which is 21. So we'll click here. Then we're going to click on the Windows tab. And we're going to grab this version here, the compressed archive.zip. So we click on that. We're going to open this up. We're going to open a second Windows Explorer window with Windows E. We're going to go to this PC, C drive, and we're just going to drag this folder right into the root of C. So now we need to add Java to our path. And the way you do that is you can press Windows I to bring up the settings screen. You're going to scroll down to the About. So we're going to click on About. This tells us information about our PC. And there's this little hyperlink here for Advanced System Settings. This brings up like a Windows 98 style dialog box. We're going to go into the environment variables. It's very important that you use the system ones down here. And we're going to double click Path, New. We're going to click Browse. And we're going to look for that folder that we just unpacked into our C drive, and we want the bin folder inside of it. So it's C:JDK21.02/bin. Press OK, press OK, press OK, press OK, close this window. Now, how do we test that Java is installed? Well, once again, we're going to open a command prompt with Windows R, CMD, and we're going to type in java-version, and we can see that Java 2102 is in fact here and ready to go. Now you'll notice that I'm always closing these windows and reopening them. When you're installing software and you're making changes to the environment, you want to start new command windows because that will inherit the environment that has just been changed by previous installations. Now that we have Java, we need to get our assembler, and we're going to use the Kick Assembler. So just Google or Bing Kick Assembler, and this is the correct link. the web.dk/kickassembler. So we'll click on that. We're going to click this first option, download kickassembler. It's going to download a zip file. We're just going to open it. We're going to press Windows E to get another Explorer window so we can drag it over to it. I'm going to go to this PC, go to the C column. We're going to make a new directory here called Commodore. And then inside of it, we're going to make a new directory, and we're going to call this Kick Assembler. Then we're going to highlight all these files and just drag it over to this folder. And now Kick Assembler is installed. To test the installation, once again, we're going to open a command prompt with Windows R. We're going to go into our Commodore Kick Assembler directory, type dir. There you can see the files. We're going to type java-jar space kick ass for kickassembler.jar. We're going to press enter, and we can see it's installed. We've used the Java runtime to run the assembler. We get the version number, and of course there's no input files, but we know it's installed. Before we leave here, we want to take a copy of that PDF and put it on our desktop, because that's going to be really useful. So we're going to type explorer space dot to launch the Windows Explorer in that directory. So we're going to right click drag this icon to our desktop, and we'll create a shortcut here. And then we can close these windows. I'm going to rename this with F2, and I'm just going to put Kick Assembler. And now we've got a reference to the documentation, which you will be referencing a lot as you learn how to use this product. Now for the most exciting thing, we're going to install the Vice emulator. So we're going to Google or Bing for Vice Emulator. And this is the website, vice-emu.sourceforge.io. So we're going to click on that. We're going to go to this download link. And we're going to grab this 64-bit GTK version right here. So we're going to click this hyperlink. It's going to take a couple seconds to start. Okay, we're going to click open. And then once again, we're going to open up a second Explorer window by pressing Windows E. And then we're going to go to our this PC C:*Commodore directory. And we're going to drag this GTK3 Vice directory right here. All right, we're going to close this zip file window. We're going to go into this folder. We're going to go into the bin directory, and we're going to sort by application. There's a lot of EXEs in here, but the one that we're concerned with is this X64SC. This is the Commodore 64 emulator. So we're going to right-click, drag this out, and then we're going to let go here, and we're going to create a shortcut to it. Close this window, and then we're going to press F2 to rename it, and we're just going to call it C64. Now to test that this is installed properly, we're going to double-click to run it. Now, if you're in Windows 11, sometimes you might get this mysterious dialog box. Search for the app in the App Store, and there doesn't seem to be any way to run it. You don't need to install an app for this task. We're not going to search one using our App Store, so we're going to click No. To get around this, you're going to right-click, open File Location, and you'll notice that it brings it to Explorer and it highlights the file. I'm going to right-click on it. We're going to choose Properties, and there's this little section down here called Security. This file came from another computer and might be blocked to help protect this computer. You're just going to check Unblocked, hit Apply. It's going to disappear from the dialog. We're going to press OK. And then we're going to double click this again. And now Vice Emulator works no problem. We're going to do some small configurations to the emulator to make it more palatable to me. So you may want to change these settings however you would like to. But these are generally the basic settings that I like to tweak. So I'm going to start in Preferences, and I'm going to go into Settings. And the first thing I want to do is make it look better. Let me just kind of move these windows around here. Okay, we're going to start in a display. We're going to go to VIC2. I think it looks better unfiltered, so I'm going to check this. And again, if you don't like these changes, you don't have to make these changes. I'm going to click on Machine, and I'm going to go to Model. I like to work with the Commodore 64C in the NTSC market. Again, choose a machine that you identify with the best that you want to write software for. All of these are really kind of the same. Of course, the different VIC chips that it emulates and SID chips that it emulates, but in terms of how we're learning to write code, it's mostly the same. Okay, we're going to press close for the moment, and we just want to kind of resize this window so we got most of the border there, but I think that looks pretty good. we're going to be using the monitor a lot. So we want to configure the monitor to make sure that that looks pretty good. Press Alt-H to bring up the monitor. The monitor is another window that's going to pop open to the side. So I'm just going to kind of position it next to it here like that. Let's just type in the word help so we can get some text on the screen. There we go. And now let's go into preferences. We're going to go into settings. We're going to go into host and monitor. From here, I like to change the background color to this blue. It's much easier for me to read personally. And then I like to change this to the bold font. Of course, like anything else, make it whatever you want. This is just the colors that I like. So we're going to hit close. Now we're going to go to preferences and we're going to click save settings. This will persist between restarts, including the positions of where the windows are. So if we close this and we're going to exit and then we restart it, it should come out right where we left it. And I'll press Alt-H and here comes the monitor with our new colors. So we're done with this for now. Now we have Vice installed and ready for us to use. There's a book called the Commodore 64 Programmers Reference. That is like insanely useful and such a key resource when writing software for the Commodore 64. There's a wonderful version of this on a blogger site called Pickled Light. So if you search for Pickled Light C64 Reference, and what this person did was they took the Commodore 64 Programmers Reference Guide and remade it using modern print techniques and just presented it as a absolutely stunning, beautiful PDF. If you scroll down a little bit here, you're going to see you can get the user's guide, which is also useful, but the Programmer's Reference Guide, this is just unbelievably useful. So we're going to grab this PDF, the main text. There we go. And then I'm going to save a copy of this by clicking this download link. So I'm going to download this. I'm going to click this little folder here. I'm going to drag this out to my desktop. You can see I grabbed two of them before. Close this. We're going to close this. And now we have this reference guide. It's super clean, super crisp, and you can use a variety of online internet print services to print yourself a copy. I actually like to support local businesses where I live, so I brought this to a local print shop, and I created this amazingly beautiful spiral bound print version of this using this PDF. And the printer was actually pretty impressed with the quality of the PDF and how easy it was for him to set and get a book printed. Okay, so now that we have that, now we need to get ourselves the main event, Visual Studio Code. So let's open a browser and we're going to search for Visual Studio Code. This is the hyperlink you want, code.visualstudio.com. So we'll click that. We're going to download for Windows stable build. So we'll just click this big button right here. Then we're going to open it to install it. Now I'm getting this message because I'm running this in what's called a Windows Sandbox virtual machine. You probably won't get this message when installing in your machine, but I'm just going to hit OK. That's totally fine. I accept the license agreement. I'm sure everything in there is totally normal. And this one here, you can just pretty much next your way through. All right, we're done with the browser for now. And then we're going to launch Visual Studio Code. Before we do anything, we just need to install an extension. We're going to click on this extensions button here. And we're going to search for the word kick, ASS, for the kick assembler. And I'm going to highlight this first one, and I'm going to leave this here for a moment on the screen. This is the one that I found to work the best. There are a few other ones that for me personally don't seem to work as well as this one. So we're just going to click this little install button here. And now we have it. So now that it's installed, we're going to click on manage. We're going to go to settings. We're going to open up this extensions tree. And we're going to click on our kick ASS assembler configuration screen. So we can just move this window over for a moment because we need to chase down some of these options. So we'll start with the first one here. We're actually not going to use a C64 debugging library. This is pretty neat, but that's probably something that should be covered in another video. For Java, Java is in our path, so just the word Java is fine. The kick assembler jar file, here's how you track this down. So we're going to press Windows E to get our Explorer up. We're going to go to C:, Commodore, kick assembler. We're going to press Alt D. We're going to press Control C to copy that to the clipboard. And then we're just going to highlight this all the way up to kick assembler, Control V to paste it. Make that a backslash, and now that's set up. We're going to uncheck the C64 debugger option. And then we're going to scroll down a tiny bit more. Now we just need the full path name to the Vice binary. So we're going to click on our shortcut, right click, Properties, right click, copy the target parameter, close this. We're going to highlight this and press Control V, and there we are. We are now configured and ready to write our first program. How exciting. So we're going to click on this icon up here to go to the Explorer. So we're going to click Open Folder to get started. We're going to go down to our C:, our Commodore directory. We're going to create a new folder here, and we're going to call it Hello World in all lowercase letters. We're going to highlight this folder, and we're going to choose Select Folder. Now it's going to give you a question. Do you want to trust the authors of this folder? Sure, it's my machine. I totally trust it. Before we drop a line of code, we want to initialize version control. Don't worry, this isn't that complicated. We click on this hyperlink here. This is the version control button. And all we do is click this initialize repository. Now the directory that we're writing a code in is ready to work with Git, and it's handled mostly automatically through Visual Studio Code. So you don't have to worry about getting into the command prompt and learning all the Git syntax. You can if you want to, of course, but if you've never used Git before, you don't have to even look at it. We're going to click on Explorer now, and we're going to create our first file. We're going to choose this little plus here with a document for a new file. We're going to type in helloworld.asm, press enter, and now we're inside the source code to our first program. Now what's interesting about Visual Studio is it gets a little flaky here and there. So at the bottom here you can see that the kick assembler language server crashed 5 times in the last 3 minutes. Visual Studio Code can become a little unstable just after you install a fresh new extension. You will find it good practice to exit and restart Visual Studio every time you install new extensions. Before we exit it, we're going to right click and pin this to the taskbar. Then we're going to close it, and then we're going to relaunch it. I'm going to click Don't Show Again. And here we are in our Hello World assembler file. So let's write our very first program. And we're going to write the most minimal, simple program just so we can get started. Now, I'm not really going to teach you assembly here, but again, I'm going to show you just enough to get rolling so you can start the learning process on your own. So we're going to press Tab a few times. We're going to change the program counter to 2C000. We're going to load into the accumulator a 0. We're going to store that at memory address D020, and we're going to use the command RTS. This program, when you run it on a Commodore 64, will change the border to black. That's all it does. So we've written our code. It's very important that you save it before you try to run it. So we're going to press Control S, and see that little solid white circle next to Hello World? It now disappears. Kick assembler will not recognize your changes until you press Control S. So be sure that that circle is gone before you run your code. So what we want to do next is compile this, turn this into a PRG file, have it launch the emulator, inject it into memory so we can run it. That sounds like a lot, but here's what you do. You press F5. And that's it. It just did all of those things. So when Vice loaded, you could see it loading Hello World, comma 1, and it runs it. It's not a basic program, so running it won't do anything, but it is in memory. And if I type in sys 49152, our program is going to run. So this shows that we are connected to our development environment, and that is fantastic. Just an interesting thing to show you. If I type in new, and I do a load $8, you'll see that it also injected a fake disk with helloworld.prg on it. Kick assembler gives you a lot of great tools to build your distribution disks for your software. It's really neat. I'm going to close this window for now. I'm going to exit Vice. And now that we've gotten our first program written, let's commit it to our version control. But we need to do a couple quick house cleaning tasks before we add this into version control. So if you look over the version control button, you'll see that there are 6 files that it wants to commit to version control. But we only want to use one file, helloworld.asm. When we ran the assembler process, you'll notice that it created a bin directory. These files are all artifacts of the compilation and build process. We don't really want those in version control. So what we're going to do is create what's called a .gitignore file. So we're going to click this little plus here, and you're going to type in .gitignore. Press enter. Now this file, you just kind of list out the files that you want to exclude from version control. So we're going to exclude the entire bin directory. Now notice how it's green right now. If I type in /bin, press enter, and I press Control S to save it, it's going to turn gray, which means version control is not even looking at it. We also want to ignore ourselves. So .git ignore, press Control S, and that'll turn gray. And you'll notice that the number in the version control icon now is a 1. The only file we want to put in version control is our hello-world.asm. So how do we commit this to version control? Well, we're going to click on the source control screen here. We're going to click on this file, and you'll notice there's a little U next to it. It says it's untracked. This means that Git is not actively tracking changes to it. Well, that's easy to correct. We just press this little plus. It says stage changes, but it's just going to add it to version control. And now it's under this changes section. If I click on it, you'll notice that it's showing me a window here, and it's actually split in half. So let's see if I can get this to be a little wider. Here we go. And you'll see that it's showing you the before and after. Well, before there was nothing, and after is our source code. So we're going to put what's called a commit message, and we're going to describe what this does. And all this does is it sets the border to black. We're going to press commit. Now our file is committed. So now we can make changes to this file, knowing that original version we can always go back to if we screw up really badly. Or we want to look at it for reference to see what we changed. So I'm going to close these other two tabs. Our program is called Hello World, and all we've done is set the border to black. Let's actually have this program honor its name and actually print Hello World out. So let's get started here. Clear piece of text down here. Hello World. We're going to terminate it with a 0 to make it null terminated text. We're going to call this done. This will be a label for our program where it ends. Oops, I need a colon here. And let's get this. Here we go. And here's our program. What this program does is it starts by loading the X index register with a 0. It's loading into the accumulator the first character in the text hello world, indexed by X, meaning it's going to look at the 0th character first, so it's an H. If a 0 was loaded into the accumulator, it'll jump to done. If not, it's going to call kernel routine, chr out, to print it to the screen. It'll increase X to look at the next letter in hello world, and it jumps back to loop. And eventually it finishes. Pretty straightforward. So let's run this and see what happens. We're going to press Control S. We're going to press F5. And there's a typo here. So let's get rid of this extra dot. And once again, we're going to press Control S. We're going to press F5. And it started behind our window. Not very useful, but here it is. And if we type in sys49152, what do you think is going to happen? Well, we're going to get some kind of garbage. We kind of see an H, and then we get a ready prompt. So something clearly is wrong here. Has to do with text encoding. By default, the text directive in KickAssembler translates those into screen codes. When we're calling JSR FFD2, we need those to be Petsky codes. So we need to add a directive to tell the KickAssembler that when we have a text directive, we want it to be converted to Petsky codes. And we do that by using the encoding directive, and in it we put Petsky upper. All right, so we're going to Control S. We're going to run this again. Click over here. Oops, let me close this. I don't think I closed it from before. All right, we're going to press F5 to run it. Here we go. We're going to click sys49152. And now we get hello world, but it's I got an H and a W and the rest are Commodore characters. Well, ASCII and Petsky are pretty different. So it says Petsky upper, so your letters need to be in all uppercase. All right, so we're going to save this again. We'll close out Vice, and we'll press F5 to rerun it. And then here we can type in sys49152, and now we get hello world. So now we have a pretty good version of hello world. Let's add this to version control, so we will now have two different programs that we can look at inside this hello world ASM. Our set border color to black, and we'll have this version of hello world that prints out the actual text hello world. So we're going to come down into our version control, and for a commit message, we're just going to put in prints hello world. And we're going to commit it. Now we're going to get a little dialog this time, and we're just going to choose always. And now our Hello World ASM has 2 files in its history that we can go back and refer to. So let's take a little bit more deeper look at the Vice monitor. So we're going to press Alt-H to bring the monitor open. And the monitor is just a wonderful piece of software. What the monitor does is it freezes the machine, and now we can inspect and look at the state of the machine, and we can slowly advance the CPU one instruction at a time to really give us some powerful tools to debug our software. We're going to look at the first quick concept of breakpoint. So if I type in the word break, it's going to show me that there are no breakpoints set. What a breakpoint does, it allows me to specify a memory address, and right before the CPU executes code on it, the monitor will stop and let us look at it before the code runs. We know that our code is at C000, so we can put a breakpoint there. And you do that by typing in break $C000. And now it's going to say a breakpoint 1 has been set. C: means it's for the computer, because you can actually use the monitor with disk drives like 8, 9, 10, and 11 if you're writing code on a disk drive. That's a whole other cool thing you can do with this. And then it says stop on exec, meaning stop in execution. So now if I type in the word break, I can see my 1 breakpoint. So to resume the computer, you just type in G and press enter, and then over here, we're back to normal. So if I run my program now, the breakpoint hits at C00 and it stops. And it shows you that we stopped in execution, it shows us the memory address, it shows us the break number, it shows us the 2 bytes of memory that are about to be executed. It shows us A2, which is the LDX mnemonic, using the immediate mode addressing. It shows us 00 next to that, which is the byte immediately next to it. That's going to be loaded into the X index register. And then across from it, you'll see 3 8-bit registers, the A, the X, and the Y, the stack pointer, and then the status flags. If you press R and press enter, it shows us kind of the same information with some headers, but it does show us a couple cool extra nifty things. LIN is where the raster is on a display. So if you're doing like raster programming, that's really good to know. And CYC is the cycle count of the CPU. And this is good when you're trying to measure how fast something runs. So we can move to the next instruction by pressing the Z key. So if I type C and hit enter, that LDX is going to load, put the 0 into the X register, and you can see the X changes from OB to OO. And now it's at the next line of code. Now here's something really cool. Because of the integration with the Visual Studio Code, it sent the labels over to the monitor. So instead of LDA and it showing us the memory address of the text, it's showing us our label.h text. That is pretty neat. Now if I press R again, you can see that the cycle moved up 2 cycles, showing us that the LDX instruction takes 2 cycles to run. Kind of neat. You can also use the D command to disassemble memory. So we can D C00, and we can see the block of our code at the top. And again, what is really neat is because we've sent over the labels, you can see where a loop starts, you could see where the program is done, and you could see our H text. Now in H text, it's showing it to you as if it were assembly instructions. But if I were to type M space.h text to show us the memory at that label, you can see the memory dump and the words hello world there. There's a lot that this monitor can do. You can type in help at any time to get a list of all the commands. And if you want any help in any particular command, you can type in help space in the command. So for example, SHL, which is show labels. And so here's some information about how to use it. Let's set another breakpoint. So I'm going to type in break. We have the breakpoint at the beginning of the code. I'm going to type SHL to show the labels that we have. And of course, there's our labels. I want to break on .done. All right. So if I press G and press enter, my code will run until it hits the done label. Now, what's really cool is if you run it just right like I did, you can see that it's literally caught mid-rendering of the words hello world. Not only did it not finish putting all the characters on the screen, but the raster is just low enough where it hasn't painted the whole line of text yet. And if you press R, we can see that the raster happens to be at line 201. This is just like really, really cool. We're going to press G to let the processor continue, and now we're back in BASIC. All right, let's close this program out, and let's do something that makes programming even easier. So this is kind of neat that we're working with sys49.152 to run it, but it is kind of repetitive. And when you do want to distribute your program, you probably want to use what's called a basic loader. This way, users of your program can just load it, '8, and type run, and it'll just work. So the way we transmorph a program to use a basic loader is pretty simple. At the very, very top, we just type in basic upstart 2, and we pass in start. This is a macro that comes with Kick Assembler, and it inserts a stub of some bytes that represent a basic program that has just one command to skip over to where basic ends to where your program starts. And that's the word start. So we need to get rid of this program counter equals C00, so program is no longer going to start at 4952. And we'll put the word start here, because this is now where our program is going to start. So we're going to save that. The save goes away. And now when I press F5, you'll notice that this time it ran. Kind of cool. And if you type in list to list the program, you could see the fake basic program. And it has sys2062. What is 2062? Basic programs start at memory just 0801 on a Commodore 64. The little stub of basic is a few characters long, and then a few characters later is where our start label is, and that's the memory just of where our program is. If you press in Alt-H to go to the monitor, and I type in SHL, we can see that the start address of start is 080E in hex, and you can use the print command on a monitor to turn that into decimal, and you can see that's 2062. So we're going to press G to let this run. And now we have the option to type in run, which will run that sys command for us, or we could just type in sys2062 to run our program. So let's commit this auto-loaded version of Hello World to our version control. And we're going to type in added basic loader. We're going to commit it. And now we have 3 revisions. Now, how do I see those revisions? Well, it's kind of neat. If you go back into Explorer and we're in Hello World ASM, down here we've got this section called Timeline. Here it's showing you all change events across time, whether it was from Git or whether it's from our own local file system. Well, if we change this filter icon to just Git history, you can see our 3 commits, and you can click on them and you can see the source code at its different points in its life cycle. So now that we have a good idea of how to use these tools, there should be just enough here for you to go out and start learning how to write assembler on your own. So where do you start in your journey? Well, you could start with 3 really simple programs to get yourself really into the world of 6502 assembler. Your first program could be an extension of our set border black program. And I would recommend looking through the Commodore's reference guide and see how you could also set the background to black and a cursor color to white or something else of your choice. And that'll lead you down to a journey of learning how memory maps work and some important memory locations of where you can put values to change the colors of the system. Second program you could write, again, extending off of this particular program, is instead of just setting the border color black, is to have an endless loop where we increment the value stored at DO20 to different colors in an endless loop. And the only mnemonics you would need to write this program are STX, INX, and JMP. So using those 3, you can create a program that just changes the border color really, really fast in an endless loop. Now, when you run your program, you're going to have to close your machine down or press run, stop, restore, because it will be an endless loop. And then a third program that you can use to slowly expand your knowledge is to extend that program to have it wait for a key press. And you're going to have to use the FFE4 kernel routine to check for a key press. The only mnemonics you would need to write this program are STX, INX, JSR, BEQ, and RTS. So those are 3 really good programs to kickstart your journey into learning assembler on a Commodore 64. You can also get inspired by looking at the example software that comes with Kick Assembler. Well, let's close this program out and open a different folder. So we're going to go to File, Open Folder. We're going to go into Kick Assembler, into Examples, and my favorite example is this first one here, Music IRQ. So we're going to double click this, select the folder, and it says 1 file. And this may not look like much. There's actually quite a lot going on, and a great way to learn how to program is look at other people's programs. So what does this do? Let's find out. Let's press F5 and see what it does. That's pretty cool. So we'll close that for now. That concludes our tour of how to set up your machine for modern software development for the Commodore platform. Hope you found this information useful. I'm probably going to start looking at some other modern tools that are out there. The next one on my radar is a program, I think it's called CBM Program Studio, that I've heard a lot about. So I'm definitely going to check that out and see if that's easier than what we have here. I know that program has a sprite editor and a character editor and a lot of other really great useful tools. So I'm kind of excited to play with that. And thanks again very much for watching this. I really appreciate it. Take care, everyone.